Hello. In this video, we're going to discuss the bounding box camera implementation in Unity. The bounding box camera is useful for generating synthetic data to train some of the computer vision algorithms such as YOLO and stuff like that. Okay, so let's jump in how I actually created this one. So let me give you an overview. So the first thing that we do on this bounding box camera implementation is, first of all, we need to assign an ID on each of the objects that we want to detect. Okay, so in this case, I have placed two robots here, and I say that I assigned object values for both of them. Then once that's done, then I'm going to use camera along with the vertex and fragment shader to actually replace the camera image with all black and replace each of these robots, the value, with its ID value. So result of the vertex fragment shader, it'll be like a texture. Everywhere else is black, but the robots, where the robots occupy, the pixels where the robots occupy, will be replaced by the corresponding robot ID. And so it's not going to be a color like I'm showing here. I'm just showing these colors just to illustrate. But in reality, the actual texture will be single float value texture with object or ID placed on where the robots are occupying, the pixels where the robots are occupying. All right. Once then we have this texture, then we're going to use the compute shader to compute the bounding box of each object that we want to detect. Okay, so that's the general idea. So let me jump on to Unity to show you how I implemented these things. All right, so the first thing is that I placed two robots here. One is the Ybot down here. This is Ybot, and that is the Xbot. Okay, each one of those objects I have assigned a script called segmentation ID, and that using this script, I assign a material with object ID. On that material, I assign an object ID. So the idea is very simple. Assign a dummy material on all over the place with object ID, so that when the camera looks at it using vertex shader, I can retrieve this value. Okay, so that's for both Ybot and Xbot. Okay, for Xbot here, I assigned 3. Ybot here, which is green or blue, I assigned 2. Okay, let me briefly go over what the segmentation ID script looks like. All right, so I have a default material and ID, and then for each renderer of that object, it gets all the renderer for the renderer, the material that are assigned to it. We assign this dummy material, and on that material, we assign a object ID on the parameter called the detail normal map scale. This is a keyword. This is a predefined parameter in the Unity. So it's not something that I created. It's already there. The reason that I'm using this is because it's that number is not really being used in my project. And so I'm assigning the object ID on that parameter. And later on in the vertex and fragment shader, I'm retrieving this as an ID. So let's jump into vertex and fragment shader. In this vertex and fragment shader, I'm not really doing anything except retrieving that detail normal map scale value. Okay, so if that value is greater than 1, then I'm returning the value. Otherwise, I'm returning 0. So result of this vertex and fragment shader is a texture that, like I said before, let me iterate, everywhere else is 0 except except on the pixels where the object occupies, and those pixel values will be the ID value of that object. Okay, so once we have that texture, then I'm using this compute shader to compute the bounding box. Okay, the advantage of using compute shader is that now I can compute the bounding box of these objects from this sample texture. I am doing it in one go. Okay, so if you imagine using a CPU to compute the bounding box, you have to iterate through the pixels until you hit this red pixel or the ID value. Then you locate the the max y, minimum y, max x, mean x, things like that. You need to iterate through. Okay, it takes a long time. But because I'm using Compute Shader, I can load this entire texture onto the GPU, and I can compute this bounding box in one go. Let me discuss how I actually how I'm actually doing it. Okay, so there's a Compute Shader here. This Compute Shader is running on each GPU core. So let's assume that we're loading this texture onto GPU, and so each pixel is being processed by each GPU core. Now, if that's the case, let's assume that we're standing on one of those GPU core that process that red pixel there, right there. It's not really red, but it's an ID number. But let's assume that we're processing that right there, the red robot's chest, the red pixel. Okay. So in that case, we know what the UV values are, UV coordinate of that pixel. And using that, we can retrieve the object ID. Here I call this segment ID. Okay. So that in that case, it's 3. So we're going to get a 3. To actually compute and store these bounding box values, I'm using a array called result. And the array element is the struct called bounds. Okay, so each element will have min x, max x, min y, max y values, each element of the result. So since the segment ID I got is 3, which is object ID, following this, you're going to get 1. Okay, so this is going to be second element of the result array. All right, and so what this function does is that it freezes everything on the GPU. Okay, and it it compares whatever the minimum x value that it currently has in the second element of result array, compare that to current x location of the GPU core, which is basically the pixel, current x location of the pixel. Compare that. If current ID x is less than minimum x, then it'll replace minimum x value with the current x value. If not, it's going to move on. It's going to do the same thing with the interlocked max. What it does is that compare IDX with a maximum x value for the second element of result array. And if it is greater than max x, replace max x. Otherwise, move on. Okay, so that's what it is running. Okay, on each one of those pixel. So if you are on this chest of the green, or if you are at the fingertip of this green guy where my mouse is, then what happens is that the max x will be replaced by idx. Okay, most likely the max x value will be, smaller than what max x idx value. Not most likely, definitely, right? In that case, the max x value will be assigned with the idx, which is the x coordinate number of x pixels at that tip location. Okay, so that's how it finds the minimum, maximum of x and y coordinates, and that gives you the bounding box location. All right. So, like I said, running this code, this Compute Shader code on each GPU core, where each GPU core processes each pixel, you can do this computation in one go. Okay. Now, there's a little bit of the performance drawback. It's because when you do interlock, you're locking everywhere else. So each pixel is actually processed one at a time, but you're still running on the GPU much faster than you compute this on a sequential process on a CPU. Okay, so that's the general idea, and let me show you how it actually works here. Okay, so in this Unity environment, when you provide location where you want to save images and the bounding boxes, I give them here. That is over here. So if I run this, it'll save images as well as bounding box CSV file. So if I go back here, all right, so you have all these images. So if you pick one of those images, such as this, you have this image, right? And then you're gonna see at the bottom, you're gonna see the bounding box CSV file. This consists of number of numbers in the column. Okay, so the first number in each row is the frame ID. Okay, so it goes from 0 to 37. So that's what you see over here from the picture 0, image 0 to 37th image. Okay, and each row basically corresponding to each image is the bounding box. Okay, so next four numbers are the x min, y min, x max, y max location of the bounding box. Next four is the second bounding box of the second object that we detect. Okay, so the way you make sure these things are correct is pick one of those picture image, and then over here use these coordinates to to generate the image with the bounding box. I have done that for pix image number 23 here. Okay, I copy those values over here. The only thing that you have to do using computer vision package in Python is that you need to flip the y-axis. Okay, that's because in the Unity I compute from bottom to top. In the CV2 it computes top to bottom. That's the only thing. If you run it, you will see image with the corresponding bounding boxes. I color these things corresponding to. I just picked up the arbitrary color here for both of them. Okay, so that's how it works. And let me give you one more thing. Let me tell you one more thing about this. Okay, so right now I have two objects, right? Well, if I have three objects, and then if I say I have three objects, and then I only have two objects, what it does is that it'll create this CSV with another four numbers at toward the end. Okay, and it'll have some numbers that are weird, some numbers that doesn't make any sense, and that's how you know that it didn't detect the third element. It didn't see any third object in the scene. So therefore, for you to get this thing to work, you need to make sure that ID here corresponds to how many objects that you want to decide, how many objects that you would like to detect. This number of objects can be more than the objects that you have in the scene, but when you place this ID, depending on which number that you're using, right? Your result is really depends on how you assign those numbers here. So for example, I have assigned 2, which is the first one, ybot, and let's say I'll assign 4 here, right? Then in that case, I don't have the third object which sits between ybot and xbot, okay, based on the ID number. So it goes from 2, and then it missing 3, but it has 4, right? Let's see what happens when you do that. So if I go over here, delete everything, rerun this. Okay, so I have 3 objects. And then let's go back. Okay, it only took that many picture. So over here, okay, so now you can see there are 4 numbers. The first object, ID2, and then the second one, which I don't have, which is supposed to be ID3, where you see a weird number. X min has the maximum value, Y min has the maximum value in the pixel, X max, Y max, both of them has 0 values. Okay, so this is where you're missing that object with that ID. But the third one, which is object ID4, we have it. Okay, so you need to make sure that when you assign these ID numbers, these numbers needs to correspond with the number of objects that you assume there are for you to detect from the camera. All right, that's it for this video. Thank you so much.